Alrighty, in this video we are going to be looking at approximations using 4 different methods. Given that our function isn't easy peasy lemon squeezy, like 1 through 6 right here. So let's say that I give you f of x is equal to 1/4 x squared from 0 to 6, and we want to estimate the area under the curve using these 4 methods. So the first method that we're going to learn is the left rectangular approximation method, which is going to be called a left Riemann sum. So a left rectangular approximation method just means that we're going to be using our leftmost value, x value, and then using that to help us form rectangles, because that's what we are trying to do here, form rectangles. We are going to be using 6 subintervals since we're going from 0 to 6 here. So I have 0, 1, 2, 3, 4, 5, 6. And what I'm going to do is, since I'm using my leftmost x value here, I'm going to have this y value at x is equal to 0. And I'm just going to move it here so that I make it a rectangle. Plot twist, that's just going to be 0. Now at x is equal to 1, I'm going to have my y value at x is equal to 1. And I'm going to move it so that I have a rectangle between x is equal to 1 and x is equal to 2 based off of my y value at x is equal to 1. So I have this lovely thing right here. Likewise, since I want 6 steps, I'm going to have 6 rectangles of a step size of 1. My next one is going to be my y value at x is equal to 2. Just going to cross it over to x is equal to 3. This is going to be my next rectangle. So that's my third rectangle right here. My fourth rectangle, I'm going to be using 1, 2, 3. My y value at x is equal to 3. And then move it right here. So notice how your y values are always going to be your height. In this case, this is my fourth rectangle. My fifth rectangle, move it to the right. And then, like I said, I want 6 rectangles. So I'm going to go from the y value at x is equal to 5 and just move it to the right. Now, as you guys look at number 7 here, you'll notice that this, once again, this is an approximation, but you'll notice that I'm not covering everything. I have this little white part right here, this little white parts, this little white part, this little white parts, and this little white part right here that I'm not taking into account. So whenever we have something like this is going to be called an underestimate. So what we're going to do now is just look at the area by counting my squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we still have my leftovers here. So something like this right here. That looks like a 0.25. This right here looks like another 0.25. This right here looks like another 0.25. So I'm just going to guesstimate this to be about 13.75-ish. You know, we don't really know what it is. Once again, it's an approximation. All right, so looking at number 8 here, instead of a left Riemann sum, we're going to be using a right Riemann sum. A right Riemann sum is basically me using my right endpoint first. So instead of starting from the left, I'm starting from the right. I'm starting up here and then moving it to the left so that I get this lovely thing right here. So that's my first rectangle. And then I have my next rectangle right here at x is equal to 5. Going from 5 to 4. And then going from 4 to 3. Then going from 3 to 2. Going from 2 to 1. Then going from 1 to 0. Now, if I were to look at this, you'll notice that a right rectangular approximation method is going to be an overestimate because we've basically covered everything under the curve and a little bit more. So notice how we covered this part right here, 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 and this part right here, covering that up. So this is going to be an overestimate. All right, so at this point, what we're going to do is go ahead and guesstimate what this is by counting my squares. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And then we have some leftovers. We have this right here, this right here, and this right here. So I'm just going to guesstimate it to be 22.5 to 22.75-ish. We don't know. So we know that it's just between 22 and 23. All right. So if a left Riemann sum underestimates and a right Riemann sum overestimates, then let's look at something like number 9, where we have a midpoint Riemann sum, and think about, is it going to be an overestimate or is it going to be an underestimate? So looking at number 9, we are looking at a midpoint rectangular approximation method, which means that instead of me using my left-hand point or my left-hand point or my right-hand point, I'm going to be using the point in the middle. So here, from 0 to 1, I'm going to use this point right here. From 1 to 2, let's see. I'm going to use this point right here. That's in the middle of 1 and 2. Between 2 and 3, probably this point right here. Three and 4 is probably this right here. Once again, notice how I'm doing the middle of my x values. One, two, three, four, 5, and then my 6 rectangle. Probably something like this. So we could see that for a midpoint Riemann sum right here, it kind of covers a little bit above the graph, and then it doesn't cover some of the graph below. So it's like a middle ground, which kind of makes sense between my left and right Riemann sum here. But I'm going to tell you that this isn't the best in terms of finding an accurate approximation. But it does get close to our approximation, though. Here, if I were to estimate this, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, probably 17, then 17 and a half-ish right here. And then I still need to take into account like this right here. So maybe 17.5-ish, who knows? But it's a pretty good approximation. All right, so our last approximation for this video in terms of graphs is going to be the trapezoid rule. So a trapezoid rule is me actually making a trapezoid between my two x values. From 0 to 1, it's not really going to make sense because it's not going to be a trapezoid because it's kind of wonky here. So I'm going to have my x values, my height, and she's going to look like that. At this point, she looks like a triangle. I know, but it's from 0 to 1, you know? We're going to cut her some slack. Now, from 1 to 2, I'm going to have my x value from 1, my x value from 2, my y values from 1 and 2. And then I'm going to connect them, and then I'm going to drop them down, since I want my area under the curve and the x-axis. And notice how here it makes a lovely trapezoid. Likewise, from here to here, I'm making a lovely trapezoid. That's the third one. Let's have a fourth one right here. Now, as you guys look at this, notice how my trapezoid is going to beat my left Riemann sum and my right Riemann sum and my midpoint Riemann sum because of how close it is to the edge of my parabola right here. Now, is this always going to work for other graphs? Probably not. But this one is a pretty good approximation right here in terms of what we're trying to estimate. All right, so we're going to count that up, and I'm going to do that, and I'm going to give you that number being 18.25. So this is approximately 18.25. All right. So in the next video, what we're going to do is look at how we could find the 4 approximations, but this time by using a table of values instead of guesstimating it using a graph. But guesstimating it using a graph is pretty helpful to understand overestimation and underestimation, which plays a big role in this unit.